Hello all, I am Sanjana, and in this video we will see about Smart Biometric Based Blood Group Detection project. So this is developed as a mini project in Saveetha Engineering College. And before getting into it, I would like to thank my mentor, Rajalakshmi ma'am, and HOD for guiding us throughout the project. So why bioprint? So in the high pressure world of emergency medicine, we often hear that time is the most valuable resource. So imagine a person is rushed into an emergency room after an accident. Every second counts. And one of the very first thing a medical team needs to know is the patient's blood group. But right now the process is stuck in the past. A nurse has to draw blood, label it, and then send it to laboratory. Then we wait. We wait for about 20 or 30 minutes for a lab technician to run a manual test in what doctors call the golden hour, the first hour where medical care is most likely to save the life. So losing half the time just to identify a blood group can be a matter of life or death. Beyond just the time delay, the current way we do is invasive. It requires needles, it causes pain, and it carries a small but real risk of infection. It also depends entirely on having a sterile lab environment and expensive chemical supplies nearby. So these resources are often not available in rural areas or completely missing at disaster site or in medical field. So this is exactly why we decided to build Bioprint. Our goal was to take blood testing out of the lab and turn it into something very simple and safe and fast as digital touch. So now we might be wondering, how can a fingerprint tell us anything about what is flowing through our veins? The answer is actually hidden in our biology. Scientific research into the lines and ridges on our fingers has shown something incredible. Our fingerprint patterns and our blood groups are not just random traits. They are actually determined by our genes at the exact same time when we were still in the womb. This means there is a deep statistical link between the loops, the whorls, and the arches on our fingertips. And your specific blood type, since your fingerprint never changed from the day you are born, they act like a permanent built-in medical ID card. Our system is designed to decode that map and predict your blood group without needing a single drop of your blood. So now we will go into the model. So the first step in our technical journey was gathering the right data. For this project, we used a massive dataset from Kaggle containing thousands of high-resolution fingerprints. So these images weren't just random, they were already carefully labeled into 8 different categories, representing the major blood groups we all know, like A positive, B negative, AB positive, B positive, etc. So in our code, we have used a tool called Kaggle Hub to download these images directly into our environment. We then wrote a script to walk through every folder, counting images and making sure we had a good variety of samples for every blood type. Seeing those thousands of files organizing into their classes was the foundation of everything on what came next. So now we have our data, and the very next process is to clean them. So once we had our data, we had to make it ready for the AI to understand it. It has to be AI ready. So this is a crucial step called pre-processing. You see, raw fingerprint scans can be messy. Some are bright and some are dark, and they all come in different sizes. So computers don't like that. They want everything to look the same. So we built a digital cleaning path. So our code takes every single image and resizes it to a standard square size of 128 by 128 pixel. We also converted them to a standard color format and performed a step called normalization. This is where we take the pixel value and scale them down so the computer can process the numbers more easily. By making every image consistent, we ensure that our AI can focus purely on the patterns of bridges rather than getting distracted by the size or the light of the photo. So after the data was clean, it was time to build the brain of a project, the CNN or convolutional neural network. We chose the CNN because it is designed to see the world exactly like human eyes does. It doesn't just look at the fingerprint as a big block of data. Instead, it looks at it in layers. The first layer of our model acts exactly like a set of filters searching for very basic things like simple edges and lines. As the data moves deeper into the network, the layers become more and more advanced. They start to recognize complex shapes, the way lines curve, and the unique patterns that define each blood group. To keep the system fast and efficient, we added pooling layers. They act like a summary, keeping only the most important details and throwing away the rest. So once that is done, we are going to train our brain. So training this brain was the most exciting part of the project. We fed our prepared images into the network and let it start learning. At first, the AI makes a lot of guesses and it gets many of them wrong. But our code uses a process where the model checks its mistake and adjusts itself to get better. We ran this process over and over for several rounds, which we call epochs. By the time the training was finished, the AI had become an expert at spotting the tiny differences between an O positive print and a B negative print. Once we were happy with how smart it had become, we saved the entire model into a single file. This is great because it means the intelligence is now portable. We can plug it into any application without ever needing to train it again. But a smart model is only useful if people can actually use it. That's why the final part of our code is all about the user experience. We created a script that handles new unseen fingerprints. When a user uploads a scan, the code instantly puts it through the same cleaning steps we used during training. It resizes it, balances the color, and then hands it over to the trained AI. Within a split second, the system outputs the predicted blood group and tells us how confident it is in that result. The impact of a system like Bioprint is hard to overstate. It's completely painless and non-invasive, which is a huge relief for patients who are afraid of needles. Because it is powered by software, it costs almost nothing to run once it's set up. It doesn't need chemicals, it doesn't need a lab, and it doesn't need a perfect technician or tool. So this makes it a perfect tool for a paramedic in an ambulance or a doctor in a remote field clinic. It's about making healthcare faster, safer, and more accessible for everyone, no matter where they are. So now instead of just looking up into the code, we can go into the live demo. So this is how our users will experience this product. So over here, once we click this start detection, it prompts the user to upload the image. So we are going to upload the image and we have to go for analyze blood group. So it has given B positive. And go for analyze another sample. A positive along with the confidence level. So this is our project. Thank you.